Hey guys, last time we found the magnitude of different vectors. This time we're going to write vectors given magnitude and direction. So first of all, how do we find the direction angle of a vector? Well, to find that direction angle, we're going to take the inverse tangent of b over a, where our vector is ab. Here's why. Now, if I wanted to find that angle theta, across from that angle is B, my opposite side, and next to it is A, my adjacent side. And we remember from geometry, opposite and adjacent means tangent. So tangent of our angle is opposite over adjacent, so B over A. And then to get theta by itself, we would have to take the inverse tangent of both sides. So that's how we end up with the inverse tangent of b over a. Just a quick thing to let you know, all of your answers today are going to be in degrees. So make sure that your calculator is in degrees before we go on. So, to find a vector given magnitude and direction, we'll take the magnitude times the cosine of our direction, because remember cosine is our x part of trig, right? So it's going to go in the horizontal part. And then we're going to take our magnitude times the sine of our direction angle, because remember sine is our y value or our vertical value. So magnitude times sine and cosine of your direction angle. So here we go. We want to find the direction angle for each of these vectors. So if I'm looking at the vector 3, 3 over 3 up 3, what's the angle there? So just looking at an equation, the inverse tangent of 3 over 3, or the inverse tangent of 1, where's tangent equal to 1? At 45 degrees. We'll do the same thing over here to find the direction angle of 3i minus 4j. So we'll take the inverse tangent of negative 4 over 3. And when we put that into our calculator, we're going to end up with negative 53 degrees. If that negative 53 bothers you, remember that's going to be down there in that fourth quadrant. If you want to add 360 to it, so that way it's a positive number, and you want to call that 307 degrees, I'm fine with that as well. So we want to find the vector in linear combination of I and j with the given magnitude and direction. So I'm going to solve this in component form and then turn it into the linear combination of I and j. Does that sound good? So to find this vector, let's call it vector v. So we want to take the magnitude, which is 7, times the cosine of our angle, magnitude times the sine of our angle. So now at 60 degrees, we know that our cosine is 1/2. And we know that at 60 degrees, our sine is square root 3 over 2. So then we can just multiply. 7 times 1/2 is 7/2. 7 times square root 3 over 2 is 7 square root 3 over 2. Now it says to write our answer in a linear combination of I and j. So v equals, we'll have 7/2 I plus 7 square root 3 over 2 j. Let's look at the next one. That's still magnitude right there. Remember, sometimes it's written with double lines instead of with single lines. Same thing. So to find our vector w, line down here, I'm going to take my magnitude of 3 times the cosine of my angle, magnitude times the sine of my angle. We know that the cosine at 210 is going to be negative square root 3 over 2. And we know the sign at 210 is going to be negative 1/2. So then we'll multiply those things together. We'll end up with negative 3 square root 3 over 2 for our x part, and negative 3 over 2 for the y part of our vector. But we need to write it in a linear combination of I and j. So we'll have w equals negative 3 square root 3 over 2i minus 3 over 2j. Now, an application of what we're doing right now, it's called bearings. So bearings are always measured clockwise from north. Okay? So first of all, remember what a compass rose looks like. We have never eat soggy waffles. So if they tell me that I have a bearing of 110 degrees, what that means is I'm going to be down over here 110 degrees. Does that make sense? Okay, so we're going to have to convert back and forth, things like that. Every now and then you'll see something like this. It doesn't come up that much on the problems that I do, but when you see west 30 degrees north, that means I'm 30 degrees north of west. And that north 60 degrees east, I'm 60 degrees north of east. Good deal. Okay. So there's a plane traveling at 400 miles per hour, and it's flying with a bearing at 40 degrees. There's a wind of 50 miles per hour from the south. If no correction is made, what is the final bearing and speed of the plane? So first of all, let's talk about the bearing. Here's north. And 40 degrees from north is where my direction angle is. Now, in our system, from the x-axis up, how many degrees is that? Yeah, that's 50 degrees, right? Since my whole quadrant is 90. So I now know that my direction angle for my plane is going to be 50 degrees. So let's write an airplane vector. We know it's going 400 miles per hour. So that's my magnitude. And then my direction is 50, so I have cosine of 50 degrees. 400, my magnitude. Sine of 50 degrees. Then we'll pop that into our calculator. 400 times the sine, or times the cosine of 50 is going to give me 257.1. 400 times the sine of 50 is going to give me 306.4. Please round everything to the nearest tenth for me. Now we want to find the wind vector. So let's draw what the wind is doing right now. Now, if my wind is coming from the south means I'm going south to north. South to north. Now, we can think about this in two different ways. Either, well, the degree angle where it's going is 90 degrees. So we could take the magnitude, which was 50, cosine of 90, 50 sine of 90. Or I'm only going up, right? All of my magnitude is in one direction, vertical. So I have nothing horizontal, all vertical. Now, if you were to go ahead and solve these, Remember, cosine at 90 degrees is 0, so that's how we get the 0 there. Sine at 90 degrees is 1, so that's how we get the 50 there. Now we want to find the resultant vector. If you remember from yesterday, the resultant means add those two vectors together. So I'm going to add 257.1, 306.4, and I'm going to add 050 to it. And our final airplane vector is going to be 257.1, 356.4. Now we want to find the direction angle of the resultant. So for the next few problems, this is the vector that we're looking at. This is the vector, here's my plane, plus the wind. So everything acting on that plane all together. So my resulting vector, its direction angle, remember we're going to take the inverse tangent, 356.4 over 200. So I'm going to take my inverse tangent of 356.4 over 257.1. And when we put that into our calculator, we are going to get 54.2 degrees. So now that's my direction angle. But what does that mean in bearings? Let's draw our little picture again. So we know our direction angle from the x-axis up over here was 54.2 degrees. So for bearings, I'm going from the north clockwise. How many degrees is that? Well, we know a whole circle, or one quadrant is 90. So we'll take 90 minus 54.2, and we'll get a bearing of 35.8 degrees. And then to find the speed, we're just going to find the magnitude of the resultant. So we're going to take the square root of, let's see, 257.1 squared plus 356.4 squared. And when we pop that into our calculator, we're going to get 439.5, and since that's speed, that's miles per hour. All right, good deal. See you guys later.